Question 9 of paper 2 of June of 2024. In the diagram, AB is the diameter of the circle with center F. AB and CD intersect at G. FD and FC are drawn, and BA bisects CAD. D1 is 37 degrees. This information here of BA bisecting CAD, so here we have BA and CAD. I want to mark that immediately on my diagram because that's not information that we often get. And you can see that D1 equals to 37 degrees is already on the diagram. 9.1. Determine, giving reasons, any three other angles equal to D1. So from our diagram, we can see that D1 is connected to the points of B and C, and that forms another angle at the circumference of A2. So we can say that A2 would be equal to D1, which is 37 degrees, and the reason is angles in the same segment. Then we can say that A2 is equal to A1 is equals to 37 degrees, and the reason would be given. And can you see that's the information that I highlighted right at the start of the question? Instead of saying given, you can also say BA bisects angle CAD. And for our third angle, we can see that the angle of A1 is part of an isosceles triangle. So we can say that A1 is equal to D3, which is 37. And we could have also said that the angle of A2 is equal to C2, which is also 37, because that is also angles in an isosceles triangle. So I would say that D3 is equal to angle A1, which is 37 degrees, and that is angles opposite equal sides, or we can say angles opposite radii. 9.2. Show that DG is equal to GC. So let me mark that with a highlighter. I want to show that DG is GC. And what I realize is that the line of FB is from the center of the circle. So if I can prove that either angle G1 or G2 is 90 degrees, then I'll have the line from the center of the circle perpendicular to the chord bisects the chord. And also what I've done is I've marked every angle as a dot that is equal to 37 degrees. Now let's focus on this line again. If I extend that line, I have the diameter. Therefore, I know that the angle of D is equals to 90 degrees. And can you see we're getting closer to G1? So I would say that this angle is 90 degrees. So for 9.2, angle D is equal to 90 degrees. And the reason is angle in a semicircle. So in this triangle, I already have 90 degrees. And I want to move towards G1. And can you see we already have A as 37 degrees and we have this whole thing as 90. So therefore the angle of GDA is equal to 90 minus 37 degrees, which is 53 degrees. So I'm saying this angle is 53. And then I can solve G1 using angles within a triangle. So therefore, G1 would be equal to 90 degrees sum of angles in a triangle. And because G1 is equals to 90, we can say that DG is equals to GC. And because we are proving it, what we have proven is that the line from the center of the circle is perpendicular to the chord. Because the line from the center of the circle is perpendicular to the chord, it will bisect the chord. Notice I don't say line from center to midpoint of chord. I'm proving the midpoint. And the midpoint exists because the line from the center is perpendicular to the chord. 9.3. It is further given that the radius of the circle is 20 units. Calculate the length of BG. So in our diagram, we have the radius of the circle as 20. And can you see that BG is part of that 20? So if I want to find the length of BG, I can see that if I find the length of FG, then BG would be the radius minus FG. So we also know that this green triangle is a right-angled triangle. So D2 would be 90 degrees minus 74 degrees, which is 16 degrees. So D2 is 16 degrees because the two angles next to it is 37 and 37, and we subtract that from 90 degrees. Then in this triangle, we have the hypotenuse, which is 20. So if you hear the word hypotenuse, can you see that I'm going to use trigonometry? So the sine of 16 degrees is FG over 20. So I would say sine of 16 degrees is equals to FG over 20 degrees, which is the radius. Therefore, FG is equals to 20 times the sine of 16 degrees. And if you use your calculator, you get 5.51 units. So if this is 5.51 units, then BG is 20 minus 5.51 units, and that becomes 14.49 units. So remember, this BG is part of the radius, and I worked out the length of FG, and therefore I can find BG. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.